Okay, so this is the last set of the molecular shape problem, and then this is the problem is now BCl3. So boron goes into center and Cl will form the bonding with the boron. So let's see where the borons are. It's actually right next to chlorine, and this is a third column, right? That's a number 3 column. So what that means is boron has 3 valence shell electrons. So boron is like 3 electrons, and boron is one of the atoms that actually does not obey octet rule. Here actually you are seeing this as an example. So these 3 electrons, and then the chlorine, as I mentioned before, it is a halogen column atom. So all they need is, I need 1 electron from the neighbors so they can form this one becomes a bond. So they are looking for 1 electron donation from the central atom to be like chlorine forming a bond like this. And this one satisfies the octet rule, and it is a neutral, right? No formal charges and so on. So it is a very easy to understand the ligand when it comes down to chlorine. And so this one, 3 electron, you have a 3 chlorine, so 3 bonds with chlorine, forming just a bond, looks like that. And once you use 3 electrons, you have none left, so no lone pairs. So what you have is you are going to have electron group geometry, which is a lone pair plus bonds, and you have no lone pairs, you have 3 bonds, there are 3. If you have a 3 electron group geometries, that is trigonal planar structures. So what goes in the middle? The one boron goes in the middle, and chlorine occupies in the corner, and they're just going to form the bonds. So if I just showing you the shape, this shape is actually same as the geometries here because there's no lone pairs, and this is trigonal planar. So again, now I'm going to show you this way: boron with chlorine, 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 and I want to show you that they're all satisfying chlorine, the satisfying octet rule, and this one is essentially symmetric. The electrons are being pulled these 3 ways, and they cancel out each other. This is a symmetric, so therefore non-polar molecule because of the shape. So remember that it has a polar bonds, but because of the shape, the molecule itself is non-polar. So another one is, if you look at the boron here, they have a 6 electron, feel like having it, and as I mentioned that boron does not obey the octet rule, does not have to obey the octet rule. So this is molecule does exist, and then they find this is an example. So this is an example of boron trichloride is non-polar molecule with polar bonds. Okay, so that's the key point of the shape. When the shape is symmetric, although the individual bond can be a polar, they cancel out each other within the symmetry of the shape in the molecule. Thank you.